Okay, lab 2 is more challenging. Let's have a look at what we're trying to do. So here's a text you can download from the Moodle and then have a look at yourself. So I maybe explain to you directly using the figures that in the second page to show you what we're trying to do. Say for example, you have an arch spanning that distance from one structure to another one, say so from a top of wall to another top of wall. So we give a variable name to it is a span, so you need to input the span. So and then we're going to create the set of a segment of arch, and then which the height of the arch is between the center and then the lowest point is the h. So we use this one, and then this is the input information. And also you need to tell you can tell the computer how many divisions you want to divide this arch into. So the program set should be able to create this structure automatically to you. Of course, all the information, span and age, and the numbers of division, you should be that visible. Sometimes if you put the two high of edge, the edge is over a half of the circle, and then you may not be able to use this program, the algorithm we're going to discuss later on to generate this arch. So you have to be careful, but otherwise the program should be able to generate this automatically. So before we actually hand on to the programming, so we need to do some math and to make sure that we got the equation right, so we can use this equation to program and to generate the coordinates. So basically what we need is that we need the coordinates of each node as I shown here, and then with this information that we create in the Excel spreadsheet with all the information in. And also you need to create information of the linkage of the nodes. So which node connects which node, create this member, and then so on and so forth. Then you can create the arch that segment by segment. So let's have a look at how can we do that. So the first thing is the coordinates. We need to calculate all the coordinates. How can we do that? And let's say let me maybe switch the camera and use the other one trying to explain to you. Okay, so as you can see that this is the structures of the last figure we have. I maybe just show this one closer to you, so hopefully you can see this one clearly for one more moment. And then I put the camera down, then we start to deriving all this information. So what we have, so I will use a sketch to derive this equation for you in here. You see you have an arch in here, and what we know the age in here. Okay, we know the age in here. So what we have, we also have the span, which is from this point to this point. So this is a span. And what we're looking for, say for example this one been divided into 6, 7, or no matter what is you like to, so maybe n segments. So we know that this is because it's a arc, so you can have a center in here. You have a center in here. So let's define that the center, that the radius of this arch is r in here, and then so we draw a line from here to here. So we will know that the distance here of this segment here will be let me line out here. So it's r minus h. Am I right? So this is r minus h. So this half should equal to this half in here should equal to span divided by 2. So use this triangular, we should have this relationship, which is the r minus h square plus the span minus 2 square should equal to r square. So we expand this one, so you have r square minus 2rh and then plus h square and then plus span square divided by 4, so equal to r square. Okay, so immediately we can see that you can cancel these two, so the r, the 2rh will equal to the h square plus the span square divided by 4. So you have that the equation in here, which is the let me figure out. So the r will equal to the h over 2 plus, and then you put this one in there, so should be the span square times h divided by 8. No, it's wrong. So the h, it should be under, right? So that's correct. So that's what you should have for r. So now you know what is r. If you have h, the height of the arch, and then you have the span, then you should be able to use this equation to figure out what is the radians should be. So once you get this, what is radians should be, then the next one, what we looking for is to find out for the i's that the node, I need to find out what is the coordinates for this one. Say for example, we're talking about the i's node. We want to find out from here. So what? How can we find out this part? So to find out this part, what we need the start angle, which in the figures here we call it theta st, the starting point. So it's a theta st. Okay. So and then the other one is from here to here. We call it this angle. We call it theta and ed. So theta ed in here. So in between this one, so depends on how many divide you want. So then if it's 10, then you use this one minus this one, that times divide by n, so give you how many small angles, small increments you have for each node. So once you get each node, the i's node, the angle should be the starting point plus the I minus 1 and then times the increments. That will be the angles you have. So which means I will have these several information, so I use the other color to write it out. So basically, if you want to find out the theta starting point, so you need this triangular to figure out. So this triangular, which means is this part, okay, is r minus h, and then divide by the sine, so which is the r in here, so give you the sine theta. So if you want to use the sine theta, use the arc sine theta, and then you should be able to find out the angle from here. So which means I can have the theta st, the starting point, should equal to the height of this one. The height of this one should be, as we mentioned here, is r minus h, because we got r already. So it's equal to r minus h. Oh, So let me get how sorry. So I can I score out it here? So score out here. So that should equal to r minus h, so which is this distance, divided by r, and then arc sine of this one will give you the sine theta. So once you get the sine theta, and then you should be able to get the sine theta, because you get this angle here, and then the other angle from here, from this line, rotate to this line in here. So should equal to the theta ed should equal to the 2, oh sorry, not 2 pi, is the pi, is a pi minus the theta st. Right, so equal to theta st. So oh sorry, so this is the this is the theta here, and then theta here. Okay, so these two we got it. So the theta increment for each one, so should be the theta, let's put the inc in here, should equal to the theta ed minus theta st, and then divide by n. You have here. So how many divisions how many division you want, and then that will divide by n. That's give you every increments in here. So after you got this one, so I can say, if you for the ice snow, the angles of that point should equal to, let's use a theta I to represent the angles of the ice node at that location. So that's between this line and this line. Okay, so this should equal to the theta I. So theta I at this location plus how many? If this is if this is number 1, this node number 2. So if this number 2, and then the increment, this one will be 2 minus 1 plus the increment, right? So we'll plus the I minus 1, and then times the increments. Oh sorry, should be the theta inc increments. So that's give you the angles of this one in here. So once you get this part, so I can get the x and y then. So if I can get x and y, so will be this one, right? So the angle in here, so angle in here. So you get, if this is the x coordinates, so this is z coordinates, so this is the y coordinate, x coordinates. So what we should have, so this is the z coordinates, this from here to here, so this is the x coordinates. So the x coordinates is equal to the radians r times cosines of the theta I, and then minus, because it's negative direction, and then z is equal to the r times the sine of it. So then we can have the coordinates in here. So the x, so as now we use array, so you use xi of these coordinates should equal to the r times which is cosine, and then theta I, and then minus in here. Okay, so yi should equal to r times sine theta I, sine theta I. Okay, so then we got the coordinates in here. So once you get the coordinates, then you can create this one and then put this one in the Excel table, and then we use a program to generate and put it in Excel table, and then we can get the answer. So before we move on, I will oh, sorry, again. I will let you have a detailed look at the deriving we got in here. So what I'm going to do is that I'm going to scan this file, and then put on the screen. So later on we can have a look at this one in more detail. So let's stop here. Okay, now we have derived the equation to generate this small arch using the truss member. So let's try to implement this in the Excel VBA programming. So let's try to open the Excel file as I shown on the screen at the moment. So make sure that you open the first spreadsheet, and then we're trying to set up a few parameters in here. Say for example, the first one, we do need to key in to input the span. So let's say we put the text in here as a reminder, input the span of the arch. Okay, so and then we also need to input the height of the arch. So this is the two parameters we need to put in. And then the second part we need to input is how many divisions you want in this segment. So how many so after that, so we can key in any number, but it has to be sensible, because your span has to be smaller than the two radians of the circle, otherwise it's not going to work. So let's put in, say for example, if this distance is 10 meter, you put the 10 meter in there. So it's 1000 millimeter, so put the unit in here as a millimeter. So the height, let's say we can put in this height as 2 meter, say for example just 2 millimeter as a test. And so we're going to divide this one, say for example 15 segments to this one. Okay, so once you key in this part, and then you can start to run this program. As we mentioned before, you need to make sure that you get the developer tab enabled, which has introduced in the first step already, so we're not going to come back to this part again. So after that, you click on Visual Basic. So that's bring up this screen, and to make it easy for us, we put half of the screen showing the spreadsheet, and then another half showing the programming. So once you open this coding window, so you just need to double click on the spreadsheet that the tab in here. So double click on this one to bring up the program with the coding windows. So in here we need to define a subroutine. So let me try to to create this one. So sub means we are programming a subroutine, and I give a name to this subroutines is the say for example your first arch, and then you press enter, so you got a space in between. So anything you type in between this sub and end sub, and that will be this program for this subroutine. And then to make it easy for you to read, as I said before, you put the tab in, so you can start program from this point. Then the first thing we want to do is that we need to read in all these datas of the span and the height and then the divisions you need. And so to read in that one, we need a variable to store this information. So what we're going to do, we're going to define, as we mentioned before, if you want to be a good programmer, just define every variables before you use it. So and declare it. So this is a different type of variables. So is it a double? It is a integer, or the other boolean one. So you need to declare this one before you use it. So let's declare span as double, and then declare, and also the height we use h to represent as double, and then we declare the n as integer. Okay, so and then after that we can use this part. So once we get this one, and then what we can do is that we can fetch the data from the Excel table here. So once you change the value in here, so the values of the variables is going to be changed automatically. When you read in, it's going to be different value. So then you can use this parameter to generate different type of the arch. So this as a first simplest examples in here. So let's use this command which I showed you last time, is the worksheets, and then we give the name of this one. Remember, it's a case sensitive, so you need to make sure you key in exactly the name of the spreadsheet in here. So it's the sheet 1 and the dot, and then so that will define which spreadsheet you are working on, and also you can locate the cells using the coordinates. So the coordinates for the spans of the arch is reading from the first row and the second column. So you put in first row and second column in here, so he will pick up the value from there, and that will return. So we also, if you want, you can put in dot value, which means you're going to fetch the value from that location, and then assign this one to span as a double variable we declared before. So once finished, you press enter. So and say if you want, you can run this program even you program, and this is the one good things for the Visual Basic. You can complete a section of the program and you can debug it. So how to debug it? As we mentioned before, you can put a breakpoint here, and click in this area. It will generate a breakpoint in here, and then you can run the program. The program will stop here. So at this moment, this line of program hasn't been executed. You can see if you move your cursor to span, you see the value is still 0 at the moment. But if you run it one more step by pressing the FA, step into, use the FA. So you can just press the FA, and then the program will run. Sorry, this line will be executed, and then you will find out that the span now is become 10,000, which is exactly the 10 meter that data has been read in. And so we can keep programming. So to make it easy for us, we stop the program and then delete the breakpoint, and then let's read in the next two. So the next two is the age. The height should equal to worksheets, and then the send spreadsheet, and cells. The location now is moving one more row downwards, is a 2.2. So second row, second column, and dot value, that's going to be assigned to h, and the n will equal to the next row. So that will be row 3, and the colon 2 and dot value. So that's going to be the numbers of divisions you want to separate this arch into. Okay, so once you have got this basic input, so the next step what we need to do is we better maybe have a look at what we have derived in our formulas. See, when you get all the span and age, so the first thing we need to work out is the r, which is shown in here. Okay, we need to follow this equation and then get the r sorted, and then after that we need to find out where this first point start, the angles between this line and this line, so the angle theta starting point, and then also we need to find out where this point ends, and then that will be the theta end point between this line and this starting point. Okay, so we need to get this calculated. And then we also need to find out that for each node to the next one, how much the angle increment is going to be. So we use the theta increment, theta NC, this one to record all this information. So we need to figure out all these informations before we can actually calculate the coordinates of each node. So to help us to remember all this, I put these slides just on the left hand side, second half of the screen, and then we can key in this equation into the VBA programming. So again, let's come back to the coding window and we continue to define the variables, and then say for example we need the radians, so let's define the r as double, and then we also need to declare the theta starting point as double. So actually, if you want to save some time, you can do it in this way. You can do theta start and then a comma, and theta and end point we use the ed, and then theta, pay attention to this one, is the case sensitive, so you need to make sure you use the upper and lower case properly. So the third one, you can declare the three variables in one go, so you can declare all this one are double, so all as double. So once we've done this part, so we can now calculate the radians. So r actually is equal to h divided by 2.0, and then plus span, span square, and divide by 8 times h. So that's the radians we have. Oh, compile error. So okay, so we may have a mistake here. Just trying to see if you try to move away from this one by press enter, they will pump up a window that compile error, and then so this is just because of the power 2. This one you need to give a space in between, so you need to put a space in here, and then to make it more efficient, so we should put a 0.0 in here, just in case if he treated this one as integer, he divide by some number and he got a 1.2, and then he will round off to 1. So to avoid this kind of situation, it's better to put a 0.0 there, so this will become a double one, so he will keep all these signs. So you can see once you put this one in, he automatically put a symbol here to indicate this is a double number instead of integer. So for the number A, it will be the same. So you put a 0.0 there and move away, he'll add this one on automatically. So now we can get the R programmed. So if you're interested to see what is R equal to, you can set a breakpoint here and then run the program to double check. You can see, and then before you run this one is 0 at the moment, so you press enter, and then the R is coded. So that's equal to the circle, the arch cut from is a radius of 7.25 meter. So and then you can get this number. You can double check whether this is correctly or not using your calculator. Assume that this is correct, so we're not going to check this anymore. So what we're going to do is that we then continue to calculate the other two, which is a starting point of the starting angle of this arch. So it's a variable theta starting point st, the one we use to store this information. We use a function called arcsine, and which is r minus the capital R minus h. So this divide by r. So that's give you the sign. So after that, you should have the theta starting point to return to store the angles, the starting point angles in here, and then make sure that you understand this part. Theta starting point is in radians. It's not in degree. Okay, so make sure that you remember this part when you program. You need to keep this in mind. So the endpoint will be theta as we derive. Let me show this screen on the left hand side, and then that's easy for you. So we derived this before, right? So the endpoint should equal to pi minus the theta, that the starting point. So theta ed is equal to pi. So the pi in Excel VBA is very special. You need to use this function to call it out. It's application dot and then pi. Oh, haha, must be something wrong. Let me put pi I. Oh, still not there. Let me check a little bit. Okay, sorry. Sorry, that's application dot pi. So that will get the pi out from this internal function, and then that's minus. Oh, sorry, that should be pi. I make a mistake here. So that should minus theta st. So that's the end angle, and then theta increment for each node should be theta inc. That's equal to the actually oh sorry, I should show you this one. Always show you this part. So that's equal to the theta theta endpoint minus theta starting point. So that's give you actually the angles between this line and this line. Okay, so after that, so you need to divide by remember we have n division, so you divide by n. So that's give you the each joint, how much angle increments you're going to have. So once we get this ready, so we can now start to figure out the x and y coordinates one by one by each node. So what we can do here, so we need to use iteration, which I already showed you before. So you can use for I equal to 1, 2, and remember the nodes will always be one more than the division you have. So say for example you have 5 division here, so the node of this arch will be 6. So you're going to be the total node you have is n plus 1, right? So that's the n equal to the numbers of trust elements that you're going to generate, and the node will be one more than that. So we're going to generate that n plus 1 numbers of nodes, and in here, but each one I need a coordinate. So to do that one, what I should do is that I need to calculate the angles of each node at that point. So to help us to remember all these variables, we declare the variables again before we use it. So we already declared the theta increment. So we then the next one, the theta I, which is the angles for each node, I'm showing in here. So it's better we use array to store this one. So the array this moment is a bit special, and then what I thinking the best way to do to avoid to use the variance array, so we use a fixed one. So what does it mean? So we're going to define empty space, say for example a 10,000 of it, and then it doesn't matter because we don't use that one that much. We maybe just use in our case we only have 15 divisions, so we maybe use 16 space, but doesn't matter, we open that space and leave it there. So which means we can get easy solution to avoid to use the variable length that the array that I need to discuss a little bit more how we that handle that one. You need to open the space one by one, so let's forget that part. Just open a big enough one to use temporary. So we declare theta, and then is 1,000 sorry 10,000 of this one, so which means your program now is enough to handle 10,000 nodes in total. And then also we declare the coordinate x is 10,000 of these coordinates as well, and then z is also 10,000 of it. I just found out. So as double, let's finish this one. So I also just find out one more small mistake we had in my previous writing in here. Type is a typo here. So the coordinates, as we mentioned before here, the vertical coordinates is z, should be z. So I mistakenly just type in y in here. So this one should be really, this one should be really z. Okay, it's not the y. So we don't have y. So it's a 2D case. Horizontal x coordinates, vertical is a z coordinates. Sorry, not y. Okay, so that's which means we use we opened the 10,000 of coordinates of x to store these coordinates. We only use 16 of them, and then 10,000 of z as well. So once we get this space ready, then we can calculate the first the angles for each node. So the theta I at this point, they will equal to the starting point, which is a theta that the st. So we have a typo error in here. So this really should be the theta st, right? Here is that st. I'll correct this one and upload to the Moodle a correct version. So this one should be theta starting point, and then plus the next node. So next node, say for example, if this is node number 1, this is node number 2. So between this one is actually 1 increments you need. So node number 2 you have 1 increments. So for the ith node you need to I minus 1 and then times the theta inc. So that's give you the exactly the angles for that node. And then we have the x coordinates xi at that point, is actually you have the angle here, so you should be able to use the cosine and sine to find the coordinates easily, which is shown here. But remember, this is z. Okay, so let's say the xi is equal to the r is the radians times the cosine and theta and then I, which you just calculate. And remember, this coordinates when this angle smaller than 90 degree, the x coordinates is in negative direction, so you put a negative in here. Okay, so minus, and then y. Oh, sorry. Again, I make a mistake. Z here. Okay, it's not y. So z is equal to r times this time. This one is a sine, and then that will be the theta I from the previous step. So once you got this one, what you can do is that this data you can emit. This is once you calculate this data, you can immediately store this data into the Excel table. So let me bring down this this PDF file first, and then show the Excel spreadsheet in here. So to make it clear, so what we're trying to do is that we not store our coordinates in this spreadsheet. So we maybe create a new one. So let's press plus and plus button in here. So we create the other one. So to make it easy to remember, we change the name to, so by double click on the name in here, so you can start to key in your own name. So we put in COOR, which is representing the coordinates. So we're going to store the coordinates in here, and then also we can create another one by changing the name to the members. Okay, so maybe members in here, and after that, so what we're going to do, these coordinates we're going to store in here. So the column number 1 is going to be the x coordinate, and then column number 2 is going to be z coordinates. So once we get this data, you can actually just copy all these coordinates and then dump into the Autodesk robot that it will generate all these nodes automatically. So now we got this coordinate, so we just need to assign this value onto the proper cell showing in the second spreadsheet. So what we're going to do, we will pick up the locations where this number should go to. So remember, now we pick up the spreadsheet is the COR, this spreadsheet. So we put a COOR in here, coordinates, and then cells, the location will connect to the node, numbers nodes. So the first node will store in the row number 1, the second will be second, right? So what we're going to do is that we put in here. So if you are working on I equal to 1, which means is the node number 1, so we put I here, which is goes to the location that row number 1, and then column number 1 is the column to store the x coordinates. You put in the number 1 in there, so that they will not change from in this program. So they always the location number column number 1. So that's a value and equal to the xi we just calculate. Okay, so the dot value, this one is by default is a dot value. So if you don't like it, you don't need to put it in. So you can leave it as it is. It's a cell dot I dot 1, and then that automatically will means that you want to assign a new value into this cell. So you don't need a dot value if you fed up by keying too many things. And then also you can store the y coordinates into the next row. So it's a COR send spreadsheet. Make sure the case are correct. It's case sensitive. So cell. Oh, by the way, I make a mistake in here. So this is, should be the cells. Okay. So cells in here. That's going to be the I dot z is going to store in column number 2. So put in number 2 in here, equal to z, and then I. So that's done. So once this done, then you close the iteration, this loop in here. So will be next I, and then this program. So far till now, you complete the part for coordinates. So if you want to have a look that how this program work out this number, you can set a breakpoint in here, and then if you run the program, something wrong in here, a sign is wrong. So let me figure out what's wrong in here. I'll come back in a minute. Okay, I found out the mistake in here. So this a sign, you cannot call it directly. You need to put in a as same as the pi. So you need to put a application dot a sign, and then that will work. So okay, once I change this one, a application dot a sign, so that's is arcsign, that function we're going to call. So let's run it, see whether this time is okay or not. So I click on run. Okay, it gets to all this one, and then you can see the R, as we mentioned before, is 7.25 meter, and then the theta angle looks alright, and then increments every time increase a little bit. So all this one ready. So the n is 15 division, so that seems correct. And what we're trying to do now, the next one, we're going to run this one line by line. So for the first step, the I equal to 1, which means we are handle the node number 1. Let me bring up the drawing, and then you can see clearly. So now we are working on this one, number 1. So the theta I supposed to be just the theta starting point. So that's 0.809. And then this I equal to 1, so minus 1 equal to 0 times this one, that's gone. And then only this one left. So we can come back here and then press F8. So he run one more line. So you got a theta I for the number 1. So then the calculate the coordinates. So the xi now is 5000. So that's correct, because the this is the coordinate, this is the x coordinates. Okay, and then z coordinates is equal to 5250, because r minus h. That's correct. So after that, the program continue to run, and then execute this line is going to put all these x and z coordinates into this two cell. Let's have a look whether this program is doing the right job or not. So press F8, then run one more time. So you see the x coordinate is stored in this cell at the now, and then run one more line, and you see the second one is coming. So if you continue to run this program, he will write out these 15 coordinates that one by one. So, and if you fed up already, so you can just press F5. So press F5, then he will jump over all this breaking point and then stop. We'll complete the program in one run. So before we do that, let's remove the breakpoint and then press F5. So the program done. So you got all these coordinates, and then these two should be symmetric. So they since doing the good job. So now we got all the coordinates. Okay. So we got all the coordinates. Theoretically, we can copy these coordinates into the Autodesk robot. You can create this dot already, and then but we still haven't finished this one yet, because what we're going to do is that we need to create all this node, and also we need to connect them together. So node 1 connect number 2, node 2 to 3, and then that will generate all these class members one by one, and then that will form the arch structures. So this is the next step we're going to continue. Let's continue programming here to finish this step, and then we run the program together. So let me click on let me stop a little bit here. So we have finished the coordinates for the nodes, and then the next one we need to connect all these elements together and then generate another data table, which is the members that will uh, define that which member connect to which one. So let's bring back the join we have done before, and then so for this one you can see what we're trying to do is that we connect all these that node together to form this element. So node 1 connect to node 2, node 2 connect to node 3, node 3 connect to node 4, so on and so forth. Then you can form the member. So when you need to find out what is the starting point of the element, the trust element number 1, then you can just need to figure out what is the starting point and what is the end point for this member, and then from that number you can find out the coordinates generated in here. So then you can locate this one that in the in the space, so you can know the coordinates, and then you can locate these nodes. So let's continue how to have a look at how can we program this one and create the data in this spreadsheet. So before we do that, as you can see that we already generate data in here. So then if you do again, you possibly can't see that what is the node coordinate, what is the what is the coordinates generated by this run, or what the coordinates generated by the next run when you run the program. So what we can do is that we better maybe clear all these spreadsheet before you carry on. So how to do this one, how to clear this one, there was a one command we can borrow. So what I can do is that we can use this command. So worksheet, and then so is the coordinates, so which spreadsheet you want to clear, and then it's again is cells, and then dot, and this time without the coordinate, just use a command to clear it. Is clear. So after you run this program, all these table going to be clear to empty. So let me have a look at what is effect after we run this program. So if you run this program, stop in here. So all this generated by previous attempt when we run this program, so it's in here. So if you click on F8, you see all this data it's gone. So then if you run again, we're going to write it back again, right? So we can remove this breakpoint and then press F5, or maybe just click on this button that continue to finish all this one. So that's what you have for the coordinates. Now, and the next one, what we're trying to do is that we're trying to create the members. So the members, we need to generate every single members down one by one. So how many we have? Total we have n, because you have n divisions and an n members. You have n segment n members. So we use I again. So for I is equal to 1 to n this time, and then then we can generate the element number 1 to number 2. So what we're trying to do in here is that we possibly better to keep the first column as the numbers of bars. Of course, it's actually the 1, 2, 3, 4, 5, 6, 7, 8, 9 already. So let's write down in here. So saying work sheets, and this time is the members, and then cells, and then I colon 1 will write only the I in, so you can store uh, the numbers of the member on the first column. So the second column will be the starting point. So the starting point, what we can have is that you can write work sheets and then members and the cells and I column number 2. That's going to store the starting points, because you're talking about the member. Say for example, you're talking about the member 1, and then it's connecting member node 1 to node 2. So the first starting point is going to be I, and then so the next position with next column here is going to store the endpoint. So let's put in here work sheets and then oh, members and then cells and then I, and the column number 3 is equal to I, because as we said, member number 1 connecting the node number 2 to number 2. So so the second node, end node of this member is I plus 1. Okay, so once you're done, and then you can put in the next I to close this iteration. So that's all. So if we can run this part, we should be able to create this part. So same as before, if you want to clear the table before you want to before you run this run of program, you can copy this line here, but however you change the name of the table to members, and then and then so the other one not change. So every time when you run to this line, and then he will clear everything in here, and I give you a clean table to start with to write all these coordinates in here. So let's start this set point in here, and then we can have a look at the coordinates and the members one by one. So let's run the program. So when you run the program, so the next line is going to clear this table, and then it's going to generate all this line by line. So we had we have debugged this program already, so we don't need to see again. So we just need to click on this one, continue. He will stop at the next breakpoint. So the next breakpoint is going to be working on this program. So in this program, it's going to so next part of program is going to work on the table members. So if you run this one step by step by press F8, and then he will run the F8 key, and then he will run line by line. So the first line he will write this is now we are working on the element number 1, and then starting node of element number 1 is node 1, and then the end node of this one is number 2. So you continue to run again. So highlight this line and then run this part again. So you will see that the second line is 2 to 3, so on and so forth. So if you had enough, you can press the continue again to run this program to complete. So that's all for this program. So once you've done this one, so actually you generate these members that using this simple, not too long, that's possibly less than 30 line of this program. It's pretty simple and then straightforward. And then you can change, say if you're not happy about the 15, you can change to 25. You can the dimension you can change, and then the height you can change, and then you can create different things. So once you've done this one, so we can actually copy and then this data into the Autodesk Log. You can generate this structures automatically. So let me show you how to do. So I think in your program you possibly need to use the different the apps that anywhere to start your Autodesk robot. In here I need to search for my Autodesk robot to possibly I can search in here. Oh, can't. And let me check. Autodesk, yeah, Autodesk robot, and okay, so Autodesk robot is started already. So what I can do is that because we only have 2D case, so what we should do is click on more, and then when we create, because it's 2D chart structures, remember we use this one, okay, the 2D case using this one. Click on this one, we generate a 2D case, the chart structure for you. So once it's done, you will have a look at this one. So there's nothing is empty here. The x coordinates is direction and z coordinate is vertical direction. So let's go to the click on start, and then click on the nodes, and then we bring back this screen for you. So when you come to this screen, you don't need to key in, you don't need to draw this line by line. So you minimize this one, and then instead you come to the coordinates here. You just copy these coordinates, and then right click, and then click on copy, and then come back to the Autodesk robot. And then once you come back here, highlight one of the cell, and then right click, and then paste. So this coordinate is generated in here. So actually the node is automatically generated already. So you hold on the shift key, and also at the same time hold on the middle buttons of your mice, and then some mice is a scroll bar. So you use the scroll bar, and then you can see the join. Oh, possibly they are not showing that properly. So what we can do is that we can use the zoom all. Use this one, zoom all, so it can show in here, and then all the nodes is generated in here. So you possibly can't see clearly. So you hold on shift key again. Use the scroll bar to scroll it to have a look. That's it. So that's the coordinates there, right? So and then you can disable the node numbers by click on this one. So they only will leave only the note on there, no number in here. So this is the this is the note we generate already. And also if you want to generate the bar, then you can click on the bars, and then this is note already generate. So what we need to do is that you need to go back to the Excel table, and then highlight the members spreadsheet, taking the second part, which is the connectivities of the different members, and again copy it and come back to the Autodesk robot, and then highlight one of the cell here, and right click, and then click on paste. So here you go, all the structures has been generated. Okay, so and then if you delete this, and then you can take this particular setting, and then so the node number gone, and then the member number gone, the node number gone. You can click on, and then switch on, switch off, switch on, switch off, and then so you can set up all this one yourself. And then so if you like, you can say, for example, later on to give a cross section to this one. Say for example, if I give a huge size of these structures in here, so I can click on this one, and then you can maybe use slightly small one, like say 89 cross section, and then add this one to the structure close, and then this one been add to this structure already. So you can assign to all the elements. So you can select, you can assign to view that so you highlight this one, and then select this one by one. You can do in this way, and then or you can the other way to do, you can put in 1 to 15 bar apply. So every bar will apply this cross section. So once you've done this one, supposed to be, if you click on the, oh, let me check. So in your computer, you possibly need to use the app anywhere to run this Autodesk Lobo. In my computer, the setup slightly different, so I have to use the Autodesk that Autodesk folder from the starting bar. So I need to from the start menu to run this Autodesk Lobo. So I start this Autodesk Lobo, and then pay attention to what we mentioned before. We use a millimeter as the coordinates. So in here, what we should do is, as soon as we come in, we got to change the coordinates to the millimeters from meter. So have a look at this one. Let's show you later on what I mean, and then click on more. So that bring up all type of the project that you can generate using the Autodesk robot. So the next one, what you need to do is that you need to click on the truss 2D, because we're using the 2D structures, only a 2D truss. So he will have only the X coordinates and then Z coordinates in here. So pay attention to the meter here. Okay, the diameter, the dimension for the lens, the unit is meter. So we need to change this one to millimeter. So structural dimension, so we can use the millimeter instead. So and then once this done, then you can click on OK. So this, and then we can come back to this part. So to generate this structure, we need to input the nodes. So you click on the nodes in here, and then he bring up the table for you in here. Remember the table here, you can key in the numbers here, and then you can generate the nodes. You can give the coordinates of the nodes, each node that one by one. Then you can generate the node from in the screen that by keying the coordinates. What we can do now, we can use the Excel table that generate these coordinates before. So using the program we just done. So what we need to do is we just need to copy the coordinates. So click on copy all the coordinates, and then come back to the Autodesk Lobo here, and then highlight the first cell, and then right click, and then click on paste, and then the coordinates generated in there. You can see these structures. If I zoom in a little bit, and but don't click in here. If you click in here, so it generate another node in there. Okay, so this is going to be another node which generate in this position. So if you accidentally click on this one and generate one node, what you can do is that you can sorry, how to highlight this one. So you can come first. You can come back to the structural model by click on the start. So click on the start. So and then click on zoom in, and all this structure is showing in here. Possibly you can't see clearly, and then if you highlight, if you move your cursor to here and then switch on the nodes, then you can see the node here clearly. So then your cursor is become a finger and a hand and fingers here. So which means you are in selecting mode. So in selecting mode, you can draw a box and then select the node you just accidentally generate by click on delete, and then this structure has been deleted. And then after that, you can have a look at the nodes you generate, and then possibly that was a mistake there already, because the first node is not from the node number 1 anymore. So this possibly will create a problem for you. So because all the coordinates we generate is 1 to 2, 2 to 3, 3 to 4, and this part. So once you have this problem, so what we need to do is possibly we need to maybe come back to the nodes, delete all these structures. Okay, so let's come back to the nodes, have a look. And then there was nothing here this moment. Okay, so there's nothing here as become a blank project again. So you highlight this one and then right click and then paste again, so it generate these coordinates. Then remember, don't click on anything, and then you switch to the bar. So again, he will bring back this window here, allow you to copy and paste the bar elements in here, and then they connect all this bar together. Remember, this one only in the nodes, no bar is generated. So we need to copy all the datas. So come back to Excel and then click on members, select the highlight the connectivities of each element, right click copy and come back here, and then just highlight one cell and right click and then paste, and the structure is generated. So that's all. So that's all you can we want to do at this moment. So then if you can switch on switch off the members and then switch on switch off the nodes in here, so you can do this part. And also you can also assign, say for example, assign a close section to the bar by selecting the section in here. So that if you haven't got this cross section set up, what you can do is that you can click on new section definition, click on new section cross section definition, so hollow section, circular hollow section, and then you can select any one of them. Say for example, I want to have a bar of 144.3 that the diameter and then the wall thickness is 3.2, circular hollow section. So I can select this one and I can click on add, and then after that I can close. You can see this cross section has been selected in here already. So once this has been selected already, and then I can come back to here. You can assign this one to each bin by click on each bin one by one, or you can do is that you can first come back to these structures. Let me highlight this one. So you highlight this one, okay? So highlight this one, and then so you come back. So once you come back to this one, highlight this cross section, and then you come back to this area, then your cursor now is become a select mode. So you can draw a box, hold on the left button of your mouse and then drag a box and then select all this box, and then you can see the line and bar you select is a 1 to 5, and then you can click on apply. So this structure then is applied with this cross section. You can see if you want to have a look at the detail, you can click on come back to the start, and then you can switch on the section shapes by click on this one, switch on the section shape. So this is a cross section bar, okay? So the size is a 1 4 can't remember now. So the cross section is a let me check, is 114.3 diameters, and then thickness 3.2. Okay, so this tutorial is trying to show you how we program in VBA and generate a simple arch using this Visual Basic programming. And Visual Basic programming is very powerful that tools, and then a lot of consulting company, and then if you one day work in different company, you will find out that they use this Excel and Excel VBA quite a lot. So the reason I'm teach this one in here is not to teach you how to draw a arch. It's teach you how to program in Excel Visual Basic, and then that going to help your future work a lot. Hopefully you find interesting. Thank you so much. Bye bye for now.